Okay, so this is a rubber band. Well, it's broken rubber band, but it still works for what I want to show you. And I'm going to use this to explain to you the concept of preload and how preload affects stroke volume. Okay, so here's a rubber band. If I stretch it a little bit, take my glasses off of this. If I stretch it a little bit, snaps back not so strongly. So, and in the interests of your education, I'm now going to take the rubber band and stretch it as far as I can. Ow. Okay. The rather painful demonstration indicated that the structure of the rubber band is such that if you stretch it a little bit, it snaps back a little bit. If you stretch it a lot, it snaps back a lot. And that's also how muscle works. And in the case we're talking about now, how muscle of the heart works. So, if at the end of diastole, the volume of the heart stretches it only this much, during systole, it'll only contract that much. But say, I don't know, say you've been exercising a lot and there's lots of blood pumping through you, so that at the end of diastole, the amount of blood which has been pumped back into your ventricles means that the ventricle is stretched this much. Because of the structure of the ventricle during systole, the force contraction is greater. So what preload is telling you is that the amount of contraction of the heart is determined by how much it's been stretched by the end of diastole. So the end diastolic volume determines the force of contraction, and the greater the contraction, the greater the stroke volume. And when you think about it, that kind of makes sense in terms of how the heart then can adjust itself to receiving different volumes during diastole.